So each time we divided these, each time we divided the height by the base, we got the same decimal when you round it to the nearest thousandths. They weren't always the perfectly same decimal all the way through, but when you round to this nearest thousandths, you got 0.466 each time. This makes no sense right now, but we'll come back to it. So let's take a look at these 4 triangles. I want you to just mentally, or you can write it down somewhere, write down or record in your brain how you would solve each of these triangles. And be ready, because I might call on you. So just think, what strategy would I use to solve triangle 1? What strategy would I use to solve triangle 2? So Brandon, what would you do on triangle 1? How would you solve that? Brandon. Brian is a student at Cy Falls who logged in. Good, Brandon, you would do Pythagorean theorem. A squared plus b squared equals c squared. So this would be the square root of 34. Factor tree at 25 plus 9. Right, so we have a way that we can solve number 1. Number 2. Albert, how would you solve number 2? Albert, how would you solve number 2? Yeah, 45, 45, 90. 12, 12, 12 root 2. Number 3, Adriana, how would you solve number 3? Welcome, Brian. Adriana, how would you solve number 3? Very good. 30, 60, 90. 6 root 3, 12. Yeji, how would you solve number 4? How would you solve number 4, Yeji? I don't know Pythagorean theorem. The thing about Pythagorean theorem is you have to have 2 sides. I mean, what would we put in Pythagorean theorem? 7 squared plus nothing squared plus question mark squared. Okay, so before today, unless you have friends or older brothers or sisters, before today, you had no idea how to solve number 4. So we need something to help us solve number 4. We know how to solve number 1, number 2, and number 3, but right now we are helpless on number 4. George, don't give it away. We are helpless. We cannot solve. I want everyone to guess what they think x is, though. I want you to just take a guess and write it down somewhere, because we're going to solve it later, and we'll come back to it. Actually, I'm going to move the x right here. Now take a guess. Take a guess at what you think x is. Take a real guess. It was a trick question, Yeji. You're right. I'm sorry. And we'll come back to the answer later. It can't be 17 because it's across from 20 degrees. If that's 20, then this is 70 degrees. So it's got to be less than 7 because 7 is across from 70, so a number smaller has to be across from 20. All right, let's move on. So why do we have trigonometry? What is trigonometry and who uses trigonometry? So trigonometry is just another way to solve for missing sides in triangles. It's just another tool we have in our toolbox. Just like Pythagorean theorem and just like our special right triangles, trigonometry only works on right triangles. It only works on right triangles. So if your triangle is not a right triangle, you need to make it into a right triangle. Okay? It only works on right triangles. Tons of people use trigonometry in the real world because not all triangles in the real world have two sides that are given to you. Not all triangles are 30, 60, 90, or 45, 45, 90. So lots of people use trigonometry. Here's some of the, real quick. It was discovered by Greek mathematicians, so kind of probably around the time of Pythagoras. And the whole reason they came up with trigonometry was because they wanted to study the stars. And trigonometry helps you do things like measure the distance from the Earth to the sun. Without our modern technology, there were very few things they could do to find out how far away the sun was from the Earth. So they used trigonometry to help them study astronomy. That's how it came about. So today, there's lots of professions that use it. Here's just a few of them. Map makers, obviously, cartographers, they use trigonometry. Composers, have you ever heard of a sine wave? That wave, musical wave. And then there's an example of the space station, the arm of the space station. One of our teacher's husbands used to work for NASA, and he worked on that arm. And he said he did use trigonometry while he was working on that arm. So it's pretty cool. Okay. So here are the three most common trig ratios. There are more out there, but I don't really even know much about them. These are the three that I know about because these help us solve our problems. So this one is pronounced sine. Sine. I know that we abbreviate it S-I-N, but we do not call it sin. We never call it sin. That is sine. We're not committing a crime. We're not sinning. So that is sine. And it really bugs me when people call it sin. The next one is called cosine. So it's just like sine with a co in front. It also kind of bugs me when people call it cos. Cosine. Cosine. And the last one is tangent. And you're going to hear the word tangent in different contexts. Like this circle is tangent, oops, sorry, my alignment's off. This circle is tangent to this line. That's a separate tangent than what we're talking about for our purposes, okay? So, or when someone says I'm going off on a tangent, that's separate than the trigonometry tangent. That's what they're talking about. They're going off on a tangent, like when you get off topic. Separate. Okay. So trigonometry just means triangle, measure. It just means you're trying to find missing measures in a triangle. That's what we're doing. That's our goal. We're missing something in a triangle and we need to find it. So take your graphing calculator out and take a look at these three buttons that you've always wondered, what do those buttons do? It's a mystery. When I press that button, I get weird decimals out and I don't know what they do. Now you're going to figure out what those buttons do. So in this unit, you always, can I stress always, need your calculator to be in degree mode. How do you check if your calculator is in degree mode? You press mode. So everybody press mode. Go. Press mode. Press it. Find mode. Press it. You need to highlight degree and press enter. So let me do it with you. On your calculator, you press mode. And you should be at a screen like this. Radians are another way that we can write angle measures. We are not going to deal with radians in geometry. I will let your next teachers deal with those. So in geometry, we're going to stick to degrees. So you need to put your cursor over to degree and press enter. And you need to make sure degree is dark. They both start with a D. Degree is dark. You have a pink calculator too? Good. Helaman, you don't have a calculator? Like you've gone through all of this whole year without a calculator? You're going to need to get one. Trig is not really something you can do by hand. Oh, Brian, I don't even know you. Okay, so just please make sure that you're always in degree mode. It's not a big deal for y'all, because once you put it in degree mode, you're in degree mode every day. But my students, when they clear out their calculator, it sticks you back in radian mode. So my students need to really make sure that they're in degree mode every day. Yes, Jenny, a scientific one is okay, but it's a little bit harder to do some of the trig stuff with. Your school has got to have a graphing calculator for you. Your school should probably supply you one. Okay, let's keep moving. We're never going to get through this if we don't keep moving. So, this is not going to mean a whole lot to you yet, setting up trig ratios. But let me just tell you how they're set up, even though you have no idea what it means yet. So in a trig ratio, the first thing you write is always the function. That's the first thing you write. So you might put cosine. That's what you would put first. The next thing that goes right here, it's always a number, is going to be the angle measure. So you put the function, which I just chose cosine, and then you put a number or a letter, and that's going to be the angle measure, and then it's going to equal a number over a number. So here's an example of what a trig equation looks like. That's an example of a trig ratio, a trig equation actually. Sine, and here's how you say it, sine of 29 equals x over 4. This right here is always the angle measure, the angle, every time. What is x? X is the side that you're looking for. So x will sometimes go here, and sometimes x will go here. So sometimes x will be in your numerator and sometimes x will be in your denominator. Okay, so we're going to find ourselves with 3 different scenarios. I'm going to let you copy those 3 scenarios down, and then we're going to talk about each one. Yes, it does matter, Yeji, but it depends on the problem. So every problem, x is going to go in a different spot, okay? Now, what I want you to pay attention to in each of these scenarios is, where is x? It's like, where's Waldo? Find x and figure out what we're going to do each time. This one, x is in the numerator. This one, x is in the denominator. And this one, x is in the angle. Taha, we're probably actually not even going to get into that until tomorrow. They help you find different missing things. If you're missing a certain thing, you might use tan, or if you're missing another thing, you might use sine. All trig is, guys, is trig is a ratio. Trig is just a division sign. And we're going to get into that later. Let's keep going. So, scenario number 1. Scenario number 1. So you wrote down those 3 scenarios. Here's number 1. When x is in the numerator of the fraction, every time you're going to multiply. And what I mean by that, let me go back to this real quick. If I were to put this over 1 and I were to cross multiply, then x would equal 19 times tan 23. Because x times 1 is x, and 19 times tan 23 is 19 times tan 23. If I were to cross multiply with this one, 19 times 1 equals x times tan 23. But a lot of times when we cross multiply, right, we do 19 times 1 divided by tan 23. So in this one, when x is in the denominator, we're going to find ourselves, dividing 19 times 1 divided by tan 23. So let's go back to this one. When x is in the numerator, every time on A, on B, on C, every time x is in the numerator, you are going to multiply. So on letter A, how do you solve for x? You do 19 times tan 23. On B, how do you solve for x? 35 times tan 54. On C, how do you solve for x? 27 times tan 62. So let's go to our calculator and do this together. So when x is in the numerator, every time you're going to multiply. What was it? 19 and 23. Okay. So 19 times tan 23. I recommend you always, always, always put the number first, because if you put tan first and you forget to close your parentheses, look, you're going to get a different answer, and that is bad. So I would always put the 19 first. I would always put the integer first, or it's not always an integer, the number first. That way you don't accidentally forget to close your parentheses. Okay? Brian, don't get off topic. So I want you to do all of these. I want you to do A, solve for x, solve for x, solve for x. Go right now in your calculator. I want you to round to the nearest, let's do nearest tenth. Yeah, your computer calc can do it, Helaman. You're right. Round it to the nearest tenth. Tawny, tell me what x equals for A. Helaman, do B, and Minjung, do C. Tahani, Helaman, Minjung. Type it in as soon as you get it. 48.2. Tahani and Minjung. So for this one, it's 8.1 if we're doing it to the nearest tenth, because the 6 tells the 0 to bump up. Minjung, 28.1. So you don't know what we're doing yet. You don't know how to set these up, but you do know that if x is in the numerator, you're going to multiply. Now let's find out how it works if x is in the denominator. We already talked about this. When x is in the denominator, you're going to divide. Get it? Denominator, divide. It's like an alliteration. Denominator, divide. Denominator, divide. So on A, you're going to do 19 divided by tan 23. And this time, you have to put the 19 first. You have to put the 19 first. 19 divided by tan 23. So you're going to put the trig function second, and I recommend you put it second whether you're multiplying or whether you're dividing. So 44.8. Try B and C. Divide those. 35 divided by tan 54. 27 divided by tan 62. Denominator, divide. Jenny, can you do B? And Quan, can you do C? So 25.4 and 14.4. There's one more scenario. This is scenario number 3. This is the scenario where x is trapped in our trig function. So in this scenario, x is trapped by tangent. Normally, when you're solving an equation, you do the opposite of what's being done to x. So like the opposite of multiplication is division. The opposite of squaring something is square rooting it. What's the opposite of tangent? George is so ready for this question. Good. That is called inverse sine. What you just wrote. That's inverse sine. Inverse tangent. Inverse cosine. So very good. When you see x and x is trapped in the trig function, you need to untrap him by doing the opposite of tangent, the opposite of cosine. So how this is going to work is in our calculator, you're going to press the second button. So you press second tan, and then you put in the fraction. So if I want to untrap x, I do the opposite of tan. I do tan to the negative 1, 13 over 27. This is tan to the negative 1, 15 over 39. Tan to the negative 1, 26 over 12. The way you're doing that on your calculator is you're pressing second tan. That'd be really funny, Taha. Oh my gosh. That would be awesome. Except I don't think he'd answer that many things correctly if he was really undercover. Second tan, I forgot what it was. 13 and 27, I'm just making that up. But you're going to get the idea. Oh, yes, I was right. So there's what it looks like when you do the inverse tangent. That's when when x is stuck in the trig function, when you're looking for an angle. So the answer is 25.7. Or if you round to the nearest angle, it would be 26, the nearest whole number. Oops. Okay, let's go back to the lesson. We're not going to do that. Okay, so now we're going to actually get into how can we actually solve these by ourselves and set them up, okay? There's no second on my computer calc. Is there a tan to negative 1 on your computer calc? So So let's pretend we're this little guy who looks kind of like a Boy Scout, and we're standing right here. Compared to this little guy, which side is opposite him? Tahani, if you had your camera plugged in, you could just show me what's on your calculator. I don't know why yours didn't get the same one. Are you in the right mode? Good, Adriana and Taha. AB is opposite of that little guy. Which side is adjacent? BC is adjacent. And then obviously AC is the hypotenuse. Now, as we're doing trig, the opposite side and the adjacent side are going to take turns. They're going to switch places and move around. But the hypotenuse is always the hypotenuse. Tahani, plug in your camera and show me your calculator so I can see what you did wrong. Did you accidentally flip your fraction? Did you not press second? You have to press second. Okay, I don't think we need to do that. So back to the warm-up. Every time, what did we get on each of these? Every time. .466 every time, remember? .466 when we round into the nearest thousandths. So I want, when you press a trig function like tangent in your calculator, I don't want it to be a mystery as to what that calculator is doing. I want you to understand that all that calculator is doing is taking a side and dividing it by a side. It's taking a number and dividing it by a number. So I want everyone to go to their calculator and type tan 25. Type tan 25. Type tan of 25 in your calculator. What happened? You got .466. Do you understand that when I have triangles of different sizes, my sides are going to be different every time. But if my angle is 25, the opposite side divided by the adjacent side is always going to be .466. No matter if my triangle is this big or this big, the ratio is always going to be the same. The sides are going to change, but the ratio of the sides are always going to be the same. So, okay, then I don't know, Quan. Do you just type tan 25? Tan 25. Tan 25. I'm trying to see, Tahani. I need you to write down in your notes what's in that box, what's in the dotted lines. The tangent ratio, because today we're just going to focus on tangent, and tomorrow we'll do sine and cosine. The tangent ratio is opposite over adjacent. So today we are not going to use the hypotenuse at all. So I need you to write this down somewhere. It's opposite over adjacent. Remember, trig is just division. All you're doing is dividing two things. So let's practice. Oops. So this says find the tangent ratio of A and B. We're not solving anything, we're just finding a ratio. So our answer should be a fraction. We're not pressing the tan button on this type of problem right here. Okay? So what I want you to do all day today is, Brandon, is X out the hypotenuse, because we're not going to use the hypotenuse today. All right, the tangent of A. The tangent of A. So everyone, you would on your worksheet, you would go to A and you would circle it. And then we learned the tangent is opposite over adjacent. Opposite over adjacent. Opposite over adjacent. And that is the answer to that problem. It's just a ratio. It's just a division of sides. So the tangent of B, what's opposite B? It's 4. What's adjacent to B? It's 3. So what would you conclude? Well, how do you find opposite and adjacent? Opposite, this is just a word. Opposite means it's across the triangle. So if you're standing at A, which one's opposite you? Is it 3 or is it 4? It's 3. 3 is opposite, and adjacent means next to. Yep, it changes every time based on the angle. So if you notice, the tangent of A and the tangent of B are reciprocals. And that's not a coincidence. That would happen every time, because you're trading with the opposite and the adjacent. Oops. Okay, try this one. Try that one. George, I want you to do the tangent of S, and Carson, do the tangent of T. Can you start at B? There's no starting. We don't start anywhere. Carson, that's not a good answer because that's not reduced. Okay, so the first thing you would need to do is X out the hypotenuse, because we don't use hypotenuse when we're dealing with tangent. So no one is allowed to use hypotenuse. Yeji, there's no starting at. You don't start anywhere. So the tangent of S means, pretend like you are standing at S. Tangent is opposite over adjacent. Opposite over adjacent, which reduces to, you get it? Okay, so we're having trouble with the words opposite and adjacent. 15 over 8. Okay, very good. Yep. 15 over 8 for George. And then we've already learned that when you find one of them, the other one is just the reciprocal. But we can go through the motions if you want. The tangent of T, opposite over adjacent. So what number is opposite T? 16. What number is adjacent to T? 30. And so there we go. They will always be reciprocals if you're talking about the same triangle. All right. So now that we've been teaching this lesson for a very long time, now we're going to actually start solving for sides of triangles. We now have enough background information to actually solve for something. So I need you to write this with me. The first thing that you do is always write the word tan. And I would actually write the template first. I would write the template with nothing filled in. So everyone write a template with nothing filled in. So in our template, in the tan function, always goes the angle. In this triangle, we're only given one angle, which is nice, other than 90. 90 is never the angle we use. So the angle that we're given is 43. And then we follow our ratio. Our ratio says opposite over adjacent. What is opposite the 43? What is opposite the 43? X. And what's adjacent to the 43? 12. And now we actually spent time practicing how to solve these. You play Where's Waldo? Where's X? If X is in the numerator, you multiply. If X is in the denominator, divide. X is in the numerator, so you multiply. And you leave the rest up to your calculator. And your calculator tells you that 12 times tan 43. Oh, I need to change my mode again because I got out of it to see what y'all were doing wrong. 12 times tan 43 is 11 point, what are we rounding to, nearest hundredth? 11.19. How come this side is so close to this side? How come this triangle is almost isosceles? How come our answer is 11.19, which is really close to 12? Very good. It's almost a 45, 45, 90 triangle. And that's why our two legs are so close in size. You use the reciprocal on the other two examples we did, not this one. Okay, next one. Next one. So let's write our equation, our template. In parentheses, the only thing ever allowed in those parentheses is the angle. So we put the angle in the parentheses. And then we know we're supposed to do opposite over adjacent because that's today's ratio. Opposite over adjacent. So which side is opposite the 23? Which side is opposite our angle? It's 18. Which side is adjacent? It's x. And then where's x? Where's Waldo? Where's x? It's in the denominator. Denominator divide. Denominator divide. 18 divided by tan 23. $42.41. Yay! Everybody with me? Can we move on? Easy smeezy. Okay, we write our template. What goes in the parentheses? The only thing allowed in the parentheses. The angle. Uh-oh, we don't know the angle. It's x. Okay, let's just write x. That'll work. Opposite over adjacent. Opposite over adjacent. You find the side that's opposite the angle. What side is opposite of x? 17, and then adjacent is 26. Opposite over adjacent. Then you play where's Waldo, where's x? Is it in the numerator, the denominator, or the angle? It's in the angle. It's trapped in the tangent function. So we're like the special agents and we have to go untrap him from the tangent function. We're going to rescue you. We're coming. The only way to rescue someone from the tangent function is to do the inverse tangent. So you do inverse tangent because that's the opposite of tan, and it's looking like you're getting 33. It says round to the nearest degree, which is a whole number. Because it's an angle this time, we're treating it differently. We treat angles different than sides. So it's a 33-degree angle. Cool. Uh-oh. We have some extra segments in our triangle. It actually doesn't matter at all. We're not going to change anything that we're doing. We first write the empty template. And then we always stick the angle in first. We stick the angle in. What side is opposite 54? And adjacent. Denominator divide. Denominator divide. I'm not going to say always, Jenny, because you have to read the directions, but for the most part, we're going to be pretty consistent about that. Yes, for the most part. 6 divided by tan 54, 4.36. Y'all know how to round? The 9 tells the 5 to bump up. Very good. Very good. That's actually all for today because that was a lot of stuff. And tomorrow